Okay. Hello, everybody. Welcome to our next session of Sunoikis's Digital Cultural Heritage for this term, the spring term or spring semester, depending on where you are. My name is Chiara Palladino from Durham University, and it's my pleasure to introduce the speakers of this session. We are going to be talking about 3D modeling and visualization. And our guest speakers are Katrine Haydock from the University of York and Despoina Sampatakou from the University of Glasgow, and our co-organizer for the Sunoikisis term, Gabriel Bodard, as well from the University of London. So before we get started, I will give our speakers the opportunity to introduce themselves in a little bit. I just wanted to remind the audience, if you're watching, if you're following us on YouTube, you have the opportunity of asking questions as well. You can post them in the chat and we will make sure to address them and answer them as soon as possible. Likewise, if you're watching live, please send us a little bit of a comment and introduce yourselves and say hi as well, so that we know you are here. With that being said, I think I will leave the stage to our speakers so that they can introduce themselves and get our session started.
Who do you want to introduce themselves first?
Anybody who is supposed to start. Katrine, would you like to get started?
Yeah, I can. Hi, everyone. My name is Katrine Haydock. I study digital archaeology at the University of York, which involves a massive amount of digital technology, 3D modeling, and how this can be applied to archaeology, both in terms of research, but also dissemination and public usage of archaeology after projects are finished.
Cool. Hi, I'm Despoina. Thank you for the introduction, Chiara. I'm currently a postdoctoral researcher at the University of Glasgow in computer science, actually. I'm a digital archaeologist, but I'm working in computer science. And we are working at the Fusion project, which essentially is a study on social interaction and how people interact with each other in social XR, so in VR environments. And my research focuses a lot on anything that has to do with social interactions and heritage or archaeology.
Great, thanks a lot, both and all. So yeah, I'm Gabriel Bodard. I'm reader in digital classics at the University of London, and 3D and archaeology are not actually my primary research area, although I've been teaching in this area, this sort of these technologies for the last 10 years or so. So I'm not entirely a fraud here. I'm basically going to give a sort of brief introduction, and I'll come back a bit at the end and talk a bit about the exercise. But most of the content on 3D will be delivered by our two experts who do work in this field more than anything else. So I really want to, just by way of introduction, to mention the fact that this is the first of 3 or 4 sessions this semester that are focused around 3D technologies. So this week we're talking about 3D modeling and visualization, and I'll talk in a minute sort of defining what we mean by that. Next week we have a session on 3D imaging and also some 2.5D imaging. In week 8 we have a session on ethics, sustainability and paradata in 3D heritage, and we'll obviously be talking about all of those things throughout as well. But that's when that will be focused on. And in week 9, there will be a session on virtual worlds and VR, with a bit more focus on those. Although again, those will have been touched on in several of the other sessions as well. So just very briefly to say a bit about the difference between 3D modeling, or we sometimes call it 3D visualization, or 3D reconstruction, or 3D design. Which is the topic of today's presentations, and next week's topic, which is 3D imaging, sometimes we call 3D capture or 3D scanning. The main difference is that when you're doing 3D imaging or capture or scanning, you are capturing the 3D geometry of an object that exists, an object that you have access to in its current state. When we're doing 3D design or 3D visualization, we're taking an object that may be lost, may be incomplete, fragmentary, or may never have existed or may not exist yet. And we're using 3D technologies to create a model of that. Those are sort of the ends of a spectrum, as it were. They're sort of platonic ideals of that definition. But a lot of work obviously combines the two in various ways. If you're reconstructing a damaged object, you might start by imaging that object and then building up from there. If you're doing visualization in a virtual environment, you might populate that virtual environment with 3D images that you've taken from existing objects, which may or may not have been enhanced, etc. So there's various things on that spectrum, but that's the main distinction. So what we're talking about today is building things and using 3D environments in various ways in archaeology. And what we'll be talking about next week is more sort of 3D scanning technologies. That's the main distinction between those two topics. So sort of on that note, I think I will hand over, and I believe Katrine is coming up next.
Yep, thank you for that great introduction. I'll just wait until it pops on the screen to get there. There we go. So my case study, which is the first one that's being brought up today, is going to be about a temple that I did reconstruction work on called Dean Hall Temple. There's the little reconstruction there up on the screen. And so this project involved an archaeological temple reconstruction for an accessible landscape walking simulator, which was designed to kind of create a recreation of not only the archaeological site, but also the landscape it was situated within. And I chose this case study today because I think it's a very good one to kind of demonstrate how you need to do the process of reconstructing from archaeological data, and also how different use cases in your 3D modeling projects can really impact the design decisions you have to make within 3D modeling. And also it was an excellent example for what you do when you're missing lots of data, which is very, very common when it comes to 3D modeling. And so a little bit about the archaeology. Dean Hall Temple is a Romano-British temple site, which means they're covered from the Iron Age to the Roman Age. And this means it's very multi-phase and has lots of different levels of construction within it. And it is centered around a natural spring, which is the reason this site was chosen. And it was also the center of a project called the Cults of the Head project. You see the lovely heads on screen. We found over 100 of those scattered around the temple, which is very interesting and unique find for the time. And that means that it was a very interesting topic to model, because whilst the temple itself is very standard, the stuff inside it was slightly unique, different. And in terms of archaeological sources available, we had the remaining walls and foundations, which you can see in the aerial photograph. And this was used as a basis alongside modern and legacy excavation data, because the site was originally excavated in the 80s and then had more excavations in, I think it was around 2015 and up to 2023. And also the rich material culture, such as the heads, played a massive part in the whole modeling process. So the basic workflow on the screen, and I don't expect everyone to memorize it. It's here kind of as a reference, and you can always download the slides and come back and look at this later. But essentially, every single stage of the modeling process.
Katrine, I'm so sorry to interrupt. It feels like the audio is breaking up a bit, so maybe you could try turning your camera off. So maybe the audio is going to come through better.
Is it better now? Is this working a bit more?
Yeah. If you speak, we will.
Yeah, let's try that.
Let's try it.
Oh, okay. Yeah, it's breaking up quite a bit now, isn't it? I can hear it. I can hear it being a bit jammy. Hang on.
I think it's a little bit better than it was.
Is it a bit better than it was before?
Yeah,
Feels
100%. Yeah.
Okay, maybe it was just a patchy spot. I apologize a bit. I'm quite far away from everyone at the moment, so the signal is not amazing. Is that a bit better now? It's now said that my Wi-Fi has gone back to full strength.
Yeah, we can hear you. Let's
Perfect.
try.
Okay. I'll try. There we go. I'll try and speak a little. Hopefully, is that even if it does crackle, it should be hearable. Hopefully. Yeah, so the temple reconstruction workflow basically is up here to show that at every single point of the reconstruction process, you have to be considering and drawing from the archaeological data available for you. And this might not necessarily be from the site itself. Sometimes you have to draw references from other contemporary sites, some places similar, if the site you're working on is potentially lacking sources in particular areas, which we'll come onto in a bit of a later section. So this was the setup we used in Blender to model the temple. I think it's a great idea if you are going to model something yourself to import reference images into Blender itself and use them whilst you're modeling. So in this case, we used the survey data to ensure spatial accuracy by physically sizing up the survey data image to the scale that we wanted and then just building on top of it, kind of from a ground up, using the image as the foundations, essentially. And this ensured that it was essentially centimeter to centimeter accurate to the actual temple on site. And now one of the big things that you will often find is that you don't have all the details, particularly when you get higher up on buildings. For example, we had no evidence around roofing for this site. And this meant that it was essentially like a blank spot when it comes to 3D modeling. And there are several things you can do if this happens during your model. The best thing to do really is try things out. So for example, we made several different roofing options for the temple and utilized other similar sites to fill the gaps. And as you can see, we have two very different styles of roofs, one with an open, one with a closed kind of central courtyard. And this is where you then get to make creative decisions based on kind of use intentions and users. For example, this model wasn't meant to be used by an archaeological audience, and it was meant to be associated as Roman by the player of the game. They should know that this was potentially a Roman temple. And we deemed that since there was no evidence for either roofing style, the roofing style with the open courtyard actually was probably more identifiably Roman for the consumer, and therefore that's the one we chose. And so one final thing I wanted to point out with this case study before I pass over onto the theory was the importance of life and lighting. So this is images of the model once it was placed into a game engine Unity, and you can really see how the shadows hit the different parts of the temple. And really one of the best things you can do to bring a model to life once you've actually made it is add in directional light, find where the sun would have been coming from and position a light either in Blender or in Unity on your model, because this can actually tell you a lot about the usage of the site in terms of which bits gets illuminated, which bits are in the dark. This can tell you how people used to live in a site, how people used to use it. Would they need candles? Would they need lighting? All sorts of things like that can be an incredibly useful asset when you're 3D modeling light, and it's often quite overlooked. So yeah, that is all I have on my case study, and I'll pass you over to Despoina for the next section where she will be discussing some of the theory behind 3D modeling.
Hi, thanks, Katrine. So yeah, I think after this great introduction by Gabby, on what 3D modeling versus 3D imaging is and the possibilities that exist, and also the great practical example on Dean Hall Temple by Katrine. We thought that it would be great to give you some a short, what we thought is a short introduction and the theoretical background of all this. Because you see, like research projects are not, and mostly should not be created in the vacuum. We normally have research questions, and that's why we create things. And they are always based on very well thought theories, actually, and methods that might not be very obvious when we are when you just see a 3D model. So yeah. First, let's begin with why we do 3D modeling and visualization in heritage and archaeology, which I think has already been quite obvious from Katrine's example. Again, please keep in mind that this is a very curated list for reasons like of time, and you will find more in your research and readings as you go on. So we normally do 3D visualization and modeling for preservation, conservation of cultural heritage. As we said before, 3D technologies actually enable heritage practitioners to record non-invasively and like fragile and danger sites. We can actually digitally archive structures, and that protects them from natural degradation, from war, tourism, and so on. There are so many archaeological sites that they are protected, and we can actually study them that way and also preserve them. And there are so many like sites that they have been destroyed due to war, and we do have them in 3D models, very well like created 3D models, and that's a way to preserve them. Of course, it's not the same, but it's a way to keep these structures preserved. Also for education purposes, and that sometimes also includes gamification, which is a whole other discussion, public engagement. So we normally care a lot about how to communicate our research to both our other experts and the wider public. So these 3D reconstructions essentially allow us to teach archaeology or heritage in schools, museums, and they can be as simple as Minecraft, for example, and or low poly, which Katrine will talk about. We can also reconstruct monuments or archaeological sites that they have either been lost or they never existed, as Gabi said. So we can actually do interpretations, as Katrine very well explained, because, you know, like especially in archaeology, normally we don't get the roof. Or we don't even get the windows in many cases. The only thing that we are left is just the footprint of like an actual structure, and we have to imagine everything else. So 3D models actually give us a great tool to test a lot of things with lighting and with other things as well. Like, for example, if you light a fire inside a structure that you think it works like that, you know, where the smoke is going to go. We can, on a similar notion, we can test hypotheses through simulation and reconstruction. Again, we can test object functions, built environments, visibility. I know I've literally, like in the last month, I've seen 2 different projects that they are reconstructions of archaeological sites, one a classical one, the other a Bronze Age one, and they literally used 3D model and 3D reconstruction to understand the visibility. So what you would be able to see if you would walking that way, for example. Another reason is like site mapping. Again, like we have drones, we have structure from motion photogrammetry, and we can create high resolution 3D models of entire sites, not only just a building, and so on, which is great because sometimes it's like, for example, we need those things in Athens. An example, Athens is very, you know, like it's like an archaeological site, and on top of it's a palimpseston essentially. So you have a lot of ancient structures beneath the modern city. So we need those archives and 3D models to know exactly where we have structures, so we will avoid, or we will make like another building, like design. We can also use it for structural analysis and material assessment. Again, to understand how different materials will react in different situations, so as simulations, for example. And it's also a great tool for low-cost digital documentation because, like, for example, I 3D scanned a lot of stuff with Polycam, which I might be able to talk about in a little bit. So we can do a lot of stuff with our phones, and then with free software, like, for example, Blender, to either engage the public very quickly or do like a very low-funded project, and so on, or unfunded studies, and so on. It can also be used for landscape archaeology. Again, we have GIS, 3D data that we can model ancient landscapes. A lot of people are working, for example, on shorelines and how climate change affect or has affected in the past archaeological sites and things like that. And on the same note, of course, like we can actually access inaccessible or difficult to access in remote locations, for example, shipwrecks, and we can have 3D models of them and study them from the comfort of our office. And very quickly on the heavy stuff, as I said, there is no research created without a philosophical, theoretical underpinning. These frameworks help the researcher essentially not only to develop the research project, but also to interpret the data and to answer the research questions they had when they came up actually with that 3D project. And these theoretical frameworks are what sometimes we call lens, like the lens that you are looking your project through, and they can literally, they are literally, in my mind, like what kind of colored glasses you are wearing when you are looking at the data and the research questions, because of course everything is biased, and when you are doing some research, you are bringing your own biases and yourself into that research. So the researcher is the center of the study. So you might be interested in exploring questions, for example, about hierarchy or economy, and you might want to use Marxism or Deleuze to do so. Or you might want to explore the role of women, let's say, or the non-binary people in a specific archaeological site that you have modeled, and you want to use gender studies theory. So you get the idea. Again, just to like a heads up, these are like a very few of my favorite theoretical frameworks that I have found that they work very well with 3D visualization modeling inheritance for various reasons. But again, these are, it's not an exhaustive list of the theories. It's just a glimpse into what actually exists out there and can be utilized when you are doing digital heritage. So I'll begin with feminism, cyborg theory, posthumanism, feminism as well. So these are great theories when we want to interrogate how bodies, technologies, knowledge intersect. And of course, in 3D visualization, these perspectives essentially highlight like who is represented, by whom is represented, who has the power, how embodiment is encoded into our 3D models, what is visual authority, and what it reinforces or resists dominant ideologies. And essentially the post-humanist feminist archaeology, which is again a great theory to build your projects. It challenges human-centered narratives. It introduces the more than human, entangled perspectives and things like that. Now on scholars, that they are quite amazing in that field. Again, this is literally just a few of them, but Donna Haraway has written in the 1985 the Cyborg Manifesto, which is something I highly recommend to everybody to read. It's a great read even today. And that's the whole cyborg theory. Comes from Colin Morgan, has written a few papers, like, for example, the one with Marta Diaz Guardamino, the human, transhuman, posthuman digital archaeologies. Anyway, everything is on the slide, and I can always feel free to reach out to send you some more reading. But this is a great one because, again, it talks a lot on about like the intersection between technology and human, essentially. Now, another group of theories are those that they are related to interpretation, embodiment as a theory, which is a great, by the way, theory on its own to explore ideas around avatars, for example, or around how we reconstruct ancient people, and the representations of past people, essentially, and the meaning making of the projects we create. Now, in that bunch, phenomenology is a great one. It's a prominent one. It argues that past spaces, landscapes, objects should be understood through embodied human experience and not only, from theory. And put a lot of emphasis on movement, perception, sensory engagement, rather than just viewing the material culture as static or, let's say, purely functional. So every modeling decision, what material we're using, what lighting, what like the uncertainty that we have, the gaps in the data, they do have their own interpretive weight, and we should take that into consideration. Again, these are theories that they work very well with 3D visualizations. Some prominent people on phenomenology, obviously, Stille, Ingold. Hermeneutics and reflexivity is a great one, as well with Jan Hodder. And cyber archaeology and interpretive simulation, Maurizio Forte is also a great one, has talked a lot about cyber archaeology, and he has argued that immersive 3D environments, they do function as simulations rather than definitive reconstructions. So again, these essentially talk a lot about the uncertainty that we have when we are creating the 3D models. And then embodiment as a practice this time, and experience in 3D visualization. That's also very applicable to 3D modeling and can be combined with any other theory that you saw, for example, the phenomenology. Again, it builds on the notion that users normally have to move through, orient themselves within, and act inside archaeological spaces, and in our cases, 3D reconstructed archaeological spaces. So meaning is produced not only through the visual observation, but through bodily engagement, spatial movement, and performative interaction. And these are very useful for also other kind of XR experiences. For example, mixed realities, augmented reality. It works better for this kind of stuff because it doesn't only put the stress on the visual and the vision as a sense, but it prompts the creator to enhance all of the senses, if that makes sense. And of course, we cannot ignore theories, methods without ethics. For example, like also authority, who gets to tell the stories, who gets to create those digital interpretations, who is this person who is doing that, and what biases, again, they carry with them. What is authenticity? How much authenticity do we include into our projects? Is it important to have huge authenticity, or a low poly, for example, is still authentic? So huge dialogues and discussions around these matters. I would recommend reading some of these people. Like, for example, Walter Benjamin, you see, like, it's 1935. He hasn't obviously written about archaeologists or 3D models, but he has brought the concept of aura. Like, aura, if you read, is like very related to authenticity. Like, for example, the aura of an authentic item, and how much of that it loses when it becomes something else, like a replica, and in our case, 3D replicas. And that provides essentially critical lens for understanding how we reproduce images and what kind of authority those images they have. And that's something that Stuart Jeffrey has expanded a lot about, like the 3D models this time, and the aura and the visual fidelity, and so on. And Jeremy Haggett has provided some background on that as well. So I won't be talking about that, but yeah, everything is here. Hugely recommended to have a look on that when you are doing your 3D modeling. And a little bit on my research very quickly, the theory, and specifically the theories that I have personally used to get an understanding of what's possible. I've used storytelling, like when I was doing my PhD, I was looking into different media that they are quite effective to communicate archaeological research to the wider public, and that included a game and a VR video. So I've used storytelling as my main mechanism to tell and retell essentially stories with the aim of first communicating archaeological research to the public, but at the same time to decolonize crypto-colonized heritage. So to do so, I used the archaeology of personhood. That's a whole discipline by Alexis Boutin. Osteobiography, which is the basis of that. And I was recreating, because I was recreating essentially the life and death of an individual in my story based on their skeletal remains. And since I was actively trying to decolonize the narrative there of the excavations, I used an awful lot of post-colonial, decolonial theory around the notion of crypto-colonialism. So even if I was doing 3D visualization, I was using a lot of, like heavy theory, let's say. And since I was creating digital media and VR immersive experiences to communicate research to the public, I couldn't escape but using various principles from digital and public archaeology, narrative theory, archaeological storytelling, as well as immersion, interaction theory to design my project and my experiments. So I used these theoretical backgrounds essentially to craft my stories, but also to design my experimental methodology and then to interpret my data. And I based everything, like my basis for everything is literally pragmatism, which is a very cool theoretical framework that allowed me to combine multiple disciplines, principles, and the experimentation that I needed to do my things. And now for what I've been doing recently in Glasgow, I work with computer scientists, and we have created a digital twin of our XR lab, which allows us essentially to directly compare users' behaviors inside and outside VR. You can see the digital twin here. This is like the actual environment, and this is the 3D model. And I was very much interested into how people handle cultural objects and how they create narratives about them. And I ran different experiments. These are my objects, which I have 3D scanned using Polycam, and then I cleaned them in Blender, and then I insert them into Unity, hosted the project with Ubiq to allow for multiple users to be inside the same room at the same time. And we are using Aria glasses. You can see them down here, which have exactly the same cameras with the Quest Pro that we used for the VR to capture metrics like gaze, proxemics, object position, head position, and so on. And I think that's me, actually.
Great. Back to Colleen again, I think. To
Katrine,
sorry.
yeah.
Sorry, Freudian slip.
I confused you.
Yeah. Oh, I'm back. Thank you, Despoina, for that amazing introduction to the theory. So I'm just going to turn my camera off just in case it causes signal problems once again. So my second case study I'm going to be sharing with you guys is a research project I've been working on called Messing with Meshes. Now, as the title suggests, this project is experimental research into the reuse of archaeological photogrammetry, which you will have an amazing talk on in a few weeks' time. But it's involved with what happens to models after they have already been produced and ways to, as the title suggests, mess with their meshes in creative ways to promote their reuse in different formats. The specific example that I'll be talking about today is the idea that you can reduce the poly count of these models to make them applicable for creative dissemination projects such as games. And in this kind of case study, what we will discuss is the importance of creativity in 3D modeling, how to manipulate a pre-existing mesh, some common pitfalls when it comes to mesh work and 3D modeling, and also how to reuse other people's assets within your own practice. So the main takeaway, if you don't really listen to anything else with this case study, is that you don't need to model everything from scratch. And this is a big thing that I believe in, is that if someone else has made something, feel free to use it. You don't need to make every single tree and plant and chair needed for your site. If someone else has made it already, you can just piggyback off them, and it will save you a significant amount of time and resources and allow you to focus on things that really you want to prioritize. And so in order to do that, I've been doing an experimental workflow in how you can turn pre-existing photogrammetry models that other people have produced of whether that be sites, objects, creative elements, and how you can turn these into models and objects usable within your own practice, even when that practice doesn't align with the initial use intention of the models. So for example, lots of these models are very high definition and are made for research. They need to be like millimeter to millimeter accuracy. And if you're making something that's going to become a creative piece, or if it's going to be just a slow-mo video in a museum, you don't need that level of accuracy. And therefore, it's actually beneficial to have ways to manipulate these meshes and make them more usable. And so, as the common phrase used for lots of museum stuff, make them able to be round on a potato. Because a lot of museums and a lot of organizations and a lot of users just don't have very high quality software. So for this kind of workflow, the main things that you need are mesh labs, which is a very useful mesh kind of cleaning manipulation tool. It's open source and it's pretty easy to download. It's literally just a click of a button. Blender and Unity. Blender is also open source, which is quite good. It's always good to try and use open source tools when you can with your modeling, and where that isn't possible, in the case of game engines, for example, it's good to use ones that are free for educational purposes, such as Unity. So as you can see from the diagram below, the actual process is relatively simple. You simply get whatever model you want, import it into MeshLab, do the decimation process, which I'll discuss further on the next slide, and then you export it, clean it in Blender, and then disseminate it using a game engine or another format. But for this example, we're using Unity. So this kind of project and the idea of manipulating meshes works particularly well on large models. We will be using this model of a church as the example today. And these can be from a really wide range of sources. Today, we're going to be looking at a model from Sketchfab, but Sketchfab is going through some changes at the moment. So in the future, that may not be the best option, but basically any model that can be downloaded in often a GLB format is best, can be used. So the process that we've been experimenting with uses the tool called Simplification Quadratic Edge Collapse Decimation. And that is a very long name for a relatively simple for the user. It's got a very complicated algorithm behind it, but for the user, it's relatively simple. You simply put in the number of faces you want your model to be, and then it will try its best to knock down the model to the amount of faces that you have suggested without trying to damage the mesh. So it will keep the shape of the object, which means that you still gain the spatial elements, such as how long it takes to go from A to B, how big something is in comparison to something else. But what you lose is the finer details. And this really comes down to user intention. If you're looking specifically at stone masonry of churches, you might not want to be doing this because you will lose the details of the specific stones. However, if you're looking at comparison of church ruins compared to the surrounding local area, you might just need the footprint of the church, and therefore you can actually knock them down quite far without actually hindering your damage. So the first thing you do is you kind of gradually do this detonation process, and it's really important to do it gradually. And this is a thing with any kind of mesh manipulation, is gradual is always best, because you cannot reverse this. If it goes too far and the model collapses on you, what ends up happening is you have to restart fully, basically, and that's never fun. So once you get down to a size of definition that you like, for example, in this one, we've got the model down to 20,000 faces, which is about acceptable to be used in, for example, a video game. That is a usable amount of faces. Once you get to this point, and you have a model you're happy with, you then need to make sure it is structurally sound. And this is done using repair non-manifold edges, which doesn't have any visual impact, but it does greatly improve the integrity of the model itself. Because many visualization softwares really dislike if you have edges that aren't solid. If they're a 2D plane doesn't really work in a 3D space, and therefore just this simple tool prevents that issue from actually causing problems for you. And once you have that, you can export your object and just pop it into any low poly environment that you would like to place your object in. And at this point, I want to highlight that this is a piece of research that I'm very interested in, because there are multiple ways of doing this, and it's something that if any of you guys are interested in, it would be great to see you guys messing about on MeshLab and coming up with your own methods and processes with this, because it's a very early area of research which hasn't really been touched on, how to reuse these big photogrammetry models. So what I've shown you is one example, but is definitely not the be-all and end-all definitive thing to do. I'd really recommend just going into MeshLab and trying it out and finding your own formulas and things that will work, because it would be great to get more kind of ideas on this topic as well. And so, I'll just go back here for a second. The model you can see in the photo is about 20,000 faces. If we go back up the initial one up here, this one, I believe it ended up being over 1 million, which if you think about the size difference there in terms of what can run an 1 million face model versus what can run a 20,000 face model, that is where you start getting the benefits from these mesh manipulation kind of tools. And so whilst I've talked about how great it is, and like you can really knock down models, there are some kind of pitfalls that you need to consider when doing something like this, and things to consider if you do decide to experiment with it on your own. One of the big ones being use intention. As I mentioned earlier, if you're looking at the fine details of a model, you kind of want to keep them, and therefore you need to make sure you're using a manipulation method that will keep those fine details and maybe like remove some of the larger details. But if you're looking at potentially the shape of the object and not the fine details, you can do the opposite. You can find something that preserves the shape and completely kills the fine details. Additionally, topology is a very big and important thing to consider. The concept of topology is far too in-depth for a very short case study, but it's always good to try and make it as clean as possible, just because this makes it a lot easier when it comes to potentially recoloring, retexturing, and machines generally run models a lot more efficiently if the topology itself is clean. And also data loss. Doing any kind of manipulation like this, you are inherently going to lose some of the initial data that was recorded. So it's very important when you do this kind of thing that you know what data you're happy to lose and you know what data you really want to keep, and that you also make a lot of backups during the process, because if you do this and you delete the original photogrammetry model, it's not coming back. And therefore you need to make sure that that original is stored somewhere, whether that be online, whether that be in a repository or just like on your hard drive. Just make sure you have backups of everything you do when you are doing these manipulations. So I've talked a bit about kind of manipulating assets yourself. Another kind of prong of this case study that I'd like to kind of highlight is the idea that sometimes you can find models that you don't need to do any manipulation to. I popped a few of these on the screen now. You can always download the slides later and check them out. All of these sites offer free for the most part. Some of them have paid, but a lot of them also do like a multitude of free assets that are completely reusable for users to use. And these range from plants and environments to full-on reconstructions of houses and buildings, and even animations that you can put on characters. And therefore you can very quickly bring your own like site to life without actually needing to do all these ancillary like creative pieces yourself. And so the use cases of reusing assets are highly varied. This can be from background visuals such as trees in the distance or some mountains in the area, to small details such as the grass on the ground, the flowers, drinking cups on a table if you're reconstructing a house, and can really be used to bring a scene to life. For example, something that is probably outside the remit of a lot of archaeologists and heritage individuals creating models is creating animals and animating people and animals and sounds and stuff. And this is when using reusable assets can be a really easy and quick way to do this, because you can find on these kind of platforms horses, deer, dogs, humans, and they can walk around your scene. And you didn't have to do any of that work. You can get someone else who's already done it and put it up and use that instead, which allows you to focus on what you really want to focus on, which is the archaeology or the heritage assets. And so things to look for when you are looking for reusable assets is particularly look for open source and open access, because this means that you can use the object and you're not essentially stealing from someone, because everyone does still have ownership over their own digital assets. A good way to identify this is for looking for the CC0 license, because this basically means that you are free to use this both personally and commercially. So you're not going to run into any sticky situations if you make something as a hobby thing and then decide to like monetize it. You're not going to have to change all your assets out. And also make sure that whatever you find is free to modify, not just use, because this allows you more creative freedom in terms of changing the color or size or like angles of things as you need to fit your project as best as possible. And even if something says that you don't need to give credit, it's always good to give credit where possible and identify that you didn't make this yourself, highlight which bits you did use, which bits you didn't use, because it just creates a better environment for everyone using these 3D assets on the space. But really the kind of capabilities with reusing assets is very endless, and I'd highly recommend doing it. I mean, the image on the screen right now, not a single one of those assets I created myself. Every single one of them is just taken from individuals who've put their assets up on the store that you can just use, and I've just then put them together into a project. So for example, I could take that scene and I could put my archaeological reconstruction bang in the center of it, and then the time has been spent creating the archaeological reconstruction, but it's still placed into an immersive and rich world without too much additional time being spent on the world itself. So yeah, that is all for this case study, and I'd like to hand you over to the third and final one, the Temple of Isis in Pompeii.
Thanks, Katrine. We might just, before we move on to that, very quickly. There's been a question about your presentation in the chat, so we might take that out of turn, as it were, and look at that. So here we go. So yeah, Elizabeth asked, when you talk about a large model, how large are you talking about? And there's a following comment also suggesting that large may refer to polycount rather than the size of the object, but I suspect that it's some combination of.
Yeah, so it's definitely a combination of both of those things. So you get large models in terms of it's an entire temple, but an entire temple could also be considered a small model if it has a very low polycount. So for example, the temple reconstruction that I made of Dean Hall would probably be classified as a small model, even though it is of a very large building, because the amount of faces the model actually has is a relatively small amount. However, when it comes to stuff like archaeological photogrammetry, generally the bigger the object, the bigger the amount of faces, because when you're recording in a very consistent scale, the bigger your object, the more points are going to be needed to fill the object in that consistent scale. In general, when it comes to this specific experiment, I was generally experimenting with models that were building sized, because with their photogrammetry, they often ended up being over 1 million faces. However, there's nothing to say that potentially if you had a model that was 500,000 faces and it was of a vase, you could also then do the same thing. I think the thing with a small model is that it needs to have a very low amount of faces. However, what classifies as a large model could be a bit more variable depending on the context.
And I guess if you've got something that's fairly small, like this sort of size, I mean, this is already a 3D print. I haven't got the vase in my office, and it's a relatively small poly count after your photogrammetry. If you start decimating that, you're going to start losing integrity very quickly, aren't you?
Yes, something like that would just become like a blob. If it's something that is very small and already has very simple poly count, for example, your object that was already 3D printable, when you do decimate that, that will just become like a block of jelly in MeshLab, and you won't really be able to do much with that. I mean, even if you could see with the church, very quickly, even at 20,000 faces, you were starting to get very spiky triangles appearing, which was fine in the context of that being a stone church, and therefore it would have had quite sharp out-jutting rocks and stuff on that face structure. But if you were doing something like potentially a vase, which has been wheel thrown and is therefore very smooth, that just wouldn't look in keeping with the object at all. And so it's very much a case-by-case experimentation, and that's why I'd really encourage some of your students to potentially try it out themselves and see what they can come up with in terms of methods and using different tools, because it would be great to kind of get a whole host of different tools that work for different objects, essentially.
Yes. And thank you for also introducing some of the issues of licenses and copyright and legality, and the difference between ethical and legal actions. So if something is CC0, you don't technically have to give credit for it, but just as if you've got the writings of, I don't know, a 19th century historian like Munson or something, his work is all in the public domain, which means you could publicly legally transcribe that work, copy that work into yours, put your name at the top and claim you've written it. As an academic, you could, if you put that in your dissertation and claim that you'd written it, that would be a complete different thing. You haven't broken the law, but it's still academic, misbehavior. So as an academic, of course, we cite, all the public domain resources that we've reused in our 3D model, because that's, that makes our work responsible and stuff. So yeah, fantastic. Again, thinking forward, in about 5 weeks' time, we'll have much more discussion of this topic. But really useful introduction. Thank you. Okay, I'm going to very quickly talk about the exercise that we're proposing for this session, and the exercise is described in quite a lot of detail at the bottom of the session page. If you found this session through YouTube, by the way, rather than coming here from SunoikisisDC, the link to the session page is below the video if you expand the description. And at the bottom of that page, there's a description of the exercise, which includes several links out to tutorial materials, to sets of data and background materials. And among them is this document, which is labeled as the photographic and other documentation for the Ecclesiasterion. So the exercise is to take this tutorial that has been written by Valeria Vitale to use SketchUp to create a model of this building. The Ecclesiasterion is one of the rooms in the Temple of Isis in Pompeii. And so I won't describe the exercise itself in any more detail. There's a lot of description of it down there. But what I will do is I will show this this set of documentation, because this qualifies as, in a sense, the paradata for the 3D model which the tutorial is showing you how to build. This is the sources upon which that 3D model was designed. It is the decisions that were made by the person who designed it. And so in many ways, it's a model for what you might do if you design your own 3D model from your own archaeological research, from looking in secondary scholarship, from photographs that you've taken or found elsewhere, floor plans that you've found or made. Record as much of that as possible in a document like this, which accompanies your 3D model in some way. So what this contains is a bunch of illustrations. So the temple of Isis in Pompeii is now ruins. It is now even more ruins than it was when it was excavated 200 or 300 years ago. So what evidence do we have for what it used to look like? So, well, we've got some drawings that were made much closer to the time of excavation. We have various different drawings. We have some plans, some other historical drawings. We have some drawings of the interior walls, which have these sort of paintings or frescoes on them. And the reason these are important is because at some point later, part of that interior wall, you see one of the panels, that's one of the panels from that wall, have been removed from the wall quite crudely and taken away to museums. So we can now take photographs of those panels, but they are smaller than the entire wall. So we know what the entire wall looked like from a drawing. We have a photograph, which may be slightly more faithful, but only of the parts of it that survived. And so there's several examples of that, some more photographs of the bits that were taken out, and drawings of the whole wall to put that into context. And these are all materials which are also provided in the download of textures that you can use to cover the walls of the model as you build it. So I'll scroll down past a few more of these. There are then the photographs that Valeria took when she was on her expedition in Pompeii herself, and these show what the remains look like now, or at least as they did in 2007 when these photographs were taken. In fact, these photographs I don't think she did take herself. These may be coming from somewhere else. But we've got these photographs. You can see when you start to see the model as it's as you build it, you'll start to recognize this wall with the 5 doorways in it. Various other views of that. Again, other views of the doorways, close-ups of some of those doorways, so you can see what's there. And this also, it's quite useful to see this because when we're reconstructing it, in the tutorial will attempt to reconstruct it as it originally was. So from the brickwork you can see on here, you can pretty much gather that probably wasn't what was visible 2,000 years ago. That probably would have been covered with a layer of plaster. That may or may not have been very, very, very thick, and so forth. So there's various elements of this that alter the way we design our model. Here are some plans. This is these are measurements that were taken by Valeria herself. She, while in Pompeii, she used a laser measure to measure the heights of those doorways, and you see they're all slightly different heights. When we design the doors in the 3D model, we'll make them all the same heights, on the assumption perhaps that variation in heights would have been concealed by slightly different thicknesses of plaster, or it may be that the heights were so close that it wasn't really detectable by people who didn't have laser finders. But that's something we have to make a decision when we design the model. Are we going to use these dimensions, or are we going to use a slightly more even dimension that we've chosen? Likewise, the floor plan, the sizes of the doorways are, so the middle one is quite a lot larger. The others are all within a couple of centimeters of 160. Probably they were all intended to be 160. Probably when they had plaster around them, that difference was lesser. We've got dimensions of the whole room and so forth. So these are the designs, the decisions that the designer of this model, we're building the model as a tutorial, but the designer of the model was Valeria Vitale, and that's the that's the documentation of how she came up with that design. So that's there really for you to sort of consider when you're building the model. Follow her instructions and use the materials she's given, but also refer back to this. Try and figure out why she's made the decisions she had. Obviously, you see from those photographs that the walls, as in some of the examples that Despoina and Katrine have shown us, don't go all the way up to the roof. So anything above that height, we're reconstructing from our knowledge of what Roman roofs look like, or guesswork, or other examples nearby, or some of the stones may have been found on the ground. Some of them we may just have to go back to Vitruvius and say, this is what he said a roof should look like. Some of them we may just be using our imagination. All of those things should be documented. How did I make this decision? What did I decide? What did I come up with? But this is the beginnings of that sort of documentation that you want to use when if you go further than following the tutorial and decide to create your own model. This should be sort of be a model for that if you're doing that sort of work. But I will stop. I will stop there. Anything anyone else to say about things to think about when you're doing an exercise on this? If not, I just say good luck to people doing the exercise, and for my students, I look forward to seeing what you come up with next week. And for people anywhere else in the world, I mean, share it with us if you'd like. It's all very cool. So we seem to have briefly lost Katrine, but
I think we lost Katrine. Yeah. Are there any other questions from the people who are watching? Feel free to use the chat. We're going to be able to see your comments. Maybe we can wait a minute to see if Katrine comes back. I did have a newbie question. I was going to address both Despoina and Katrine. And I think Katrine touched on this very briefly in terms of software available for people to do this kind of work, since Sketchfab, which was one of the most used ones, is undergoing some changes. So what recommendations do you have for people who would be willing to continue testing and continue playing with this beyond the sort of the space of a trial subscription and things like that? Is there anything that you would recommend?
I think Katrine will be better to do that, to address this question, because I'm mostly doing visualization, so 3D scanning. And for the 3D scanning, yeah, things like Polycam are quite amazing. I've done all my experiments with that, but that's again the visualization aspect. On the 3D modeling, I mean, I believe both Blender and Unity are free. But they do require higher, they do have a learning curve. Sketchfab is always a very user-friendly, I would say. I can't remember what else I've used, because I've mostly used Sketchfab. So again, I think Katrine. Unfortunately, we lost here, but.
Yeah, I think so. SketchUp, which is what we use for the exercise, is quite good for sort of architectural style modeling. It's not so good if you, for example, were trying to recreate a damaged vase or something like this. That would be something that Blender is much better for that. Depending on the sort of quality of what you want to do for sort of relatively low scale things that you might want to build, there are tools like Tinkercad, which you can just sort of throw something together quite quickly. There's a very, very limited maximum poly count on that, and not a huge sort of set of functionality or whatever, but but there's all sorts of professional tools you can use, I'm some of them are designed for building engineering applications and things like this. There's professional CAD software, but I think Blender is the most popular that I can see among academics for the sorts of things we do. I can answer the question that we've just been discussing, which is recommendations for software.
Okay, I'm so sorry. My Wi-Fi just like completely tanked, and I had to find like a backup very quickly. But so was it recommendations for software? Was the question?
For modeling? Yeah.
For modeling, yeah. So Blender is very popular because it's open source and it's free, and therefore anyone can download it. One that is very popular with 3D modeling artists. So if you're planning on doing this commercially, potentially within like outside of heritage, Maya is very, very popular amongst them. However, it is very expensive and you can get personal licenses for it, but it's one of those things that's very much you have to invest in rather than it being something that's just cheap and cheerful to pick up. Ultimately, a lot of them do very, very similar functions. The main difference is whether it's a creative software or a CAD software. So you've got Autodesk, SketchUp, those ones which are more CAD software, in which case you're going to be getting much better accuracy and design elements in terms of like you're able to measure things by the millimeter, you're able to change from meters to feet, that kind of thing very easily. And you can generate orthographic plans, you can have different views, that you can do physics and stuff like that. Mm-hmm. But then the other side of it is creative softwares such as Blender, where you're able to do a lot more stylization. You've got a lot more access to different colors and textures and patterns and materials as well. So it really depends on the purpose of your model. If you're making it for research and you want to create essentially an architect's drawing of a site, using a CAD software is probably your best option. If you're wanting to make a really colorful, stylized reconstruction, which is going to be put on a poster for a museum, for example, then something like Blender, where you do really bright colors and make it really pretty, that's probably your best bet. So it really depends on your use intention.
Thank you. Yeah, brilliant. I've also just posted in the chat a slideshow with some suggestions of software and a couple of outlines for different pieces of software that people use. Yeah.
I think we have a question that has been just posted in the chat.
Mm-hmm.
I think it's a multi-message question.
Mm-hmm.
Essentially, there's a number of assumptions that are made when recreating a location. How are these assumptions or variations historically accounted for?
Can I take this one? Because I have thought huge on that. But I do have two questions. So first of all, what do we mean historically accounted for? I suppose we mean authentic again. There is a huge bibliography on authenticity. So it's a huge discussion. So essentially, it depends on the use. I think that was quite clear from Katrine's talk as well, with the low poly especially. It depends on what exactly are we trying to do. And when you're asking a real location, I suppose we mean an archaeological site, for example. And like the assumptions that shocked you, I suppose, is like what kind of roofing or windows or materials or colors. That kind of stuff normally is assumed. Again, it depends on the use. If it is like there is like the possibility that we are literally experimenting with a model. So in that case, we don't have to historically account to somebody for that because it's like for research. So we are very clear that we don't know how the roof was and we are trying 10 different potential roofs. So there is no reason to account for something. We are literally trying to figure out what would work. This could apply mostly, in my understanding, when we are communicating our finds to the audiences, like wider audiences. Now, in that case, again, depends hugely on if we are talking about historical or, sorry about my cat, he complains hugely right now, so it's the wrong time. But it depends on if we are talking about historically documented sites or, let's say, prehistoric sites, which are not clearly, because they are prehistoric, they are not documented. So, for example, I'm a Bronze Age archaeologist, and everything we find, they are literally that much. So everything above that has to be assumed. In that case, the only workaround I have found is to be very, very clear that what you are reconstructing is assumption and the level of assumption. I have done exactly the same when I was recreating the stories about the person in Grave Circle 5. I was based, it's a storytelling. So storytelling, we can shock you even more with the assumptions that we make about people. So we try to be very upfront, saying, you know, that this is fiction. This is fiction, this is not fiction. This is based on this osteological report. This is not based on something, it's imagination, if that makes sense. So yeah, I think that's my answer. I hope it makes sense.
Yeah, I think part of the question may also have been about how do we document that those sorts of decisions. And a short answer to that is look into the concept of paradata. This is something that's been described. There's several papers about this, specifically with reference to 3D archaeology and 3D cultural heritage, is how we document the decisions that we've made, and these may be assumptions, but they also are about where that evidence comes from. There's a couple of pieces about this in the bibliography on this section. So again, if you find below the video, there's a link to the session page. One of the required readings, Valeria Vitale's paper on visual secondary sources, that has some discussion of the concept, and the first of the further readings there, Hugh Denard's introduction to the London Charter. The London Charter, especially chapter 4 of the London Charter, is all about how we document these sorts of decisions. There's also a volume specifically on paradata that Hugh Denard and others edited, that talk a lot about those sorts of decisions and how you make those decisions. And it's true that you have to be very, very careful. You have to be uncomfortable with making those sorts of assumptions, because you have to be careful about it.
Yeah, I'd just like to add in terms of getting around these assumptions and how the fact that it's inevitable. If there's a gap in the data, you're going to have to fill it in order to make something that is actually 3D. I really like using kind of a museum conservators approach. The idea that from a distance, it all looks like one thing. And then when you actually get close, it's visible repair. And you can kind of apply the same to 3D models in some way. It's not very commonly done, but I do think it would be great in terms of something for people to adopt, the idea that, like, if you don't have a wall, you potentially make it significantly less detailed than the walls that you do know exist. And so there's a very clear boundary between what has been created that is real and what has been created that is fictionalized. So from a distance, you still get the full building with 4 walls. But actually, when you get up close, you realize that one of those walls is essentially just a facade and mesh that's just there. Potentially doing this by using different colors, maybe making it slightly off color compared to the rest of the buildings, and having a paradata note saying anything that's in this specific shade of brown is reconstructed, anything that's in this specific shade is like recreated, essentially, like making the difference between the two. And doing stuff like that, I think, is something that it's very much a difficult topic that hasn't really been broached massively in terms of like what you do when you have a model that includes real and fictionalized elements. There isn't essentially a best practice for like the core way of doing it, but it's something that definitely needs to be focused on and kind of developed a bit more.
And on that, that's about 3D modeling. Yeah, on that, because I totally get what you are saying on feeling uncomfortable altering. Yes. So there is a whole also bunch of stuff in Venice Charter about architecture. So like actual standing architecture. So for example, when you are reconstructing things from marble, let's say, you normally have like a very, very light white marble to fill in the gaps of like the temple that you are reconstructing, to make it very clear to the visitor without even having a footnote, because they are literally walking, to say, oh, see, this is very white. Oh, yeah, that's an addition. Clearly, it's an addition. And there are all sorts of things, like, for example, when you have like the column that you put like a shorter thing on top instead of the whole thing, to just indicate that there should be a roofing there, but we don't know what's above that. Again, that's in Venice Charter, but I'm sure London Charter as well has tons on that.
Yes, and to come back to Katrine's suggestion of using different colors, some people have recommended almost a sort of traffic light system, right, where you've got, the object has the absolutely incontrovertible parts of the object that are there, the bits that you've had to add but you're absolutely sure they're right, the bits you've had to add slightly more speculatively, and the bits that you're completely imagining, and so you might use sort of green, amber and red to color those. Other people prefer to, rather than say how confident am I, to say what sort of evidence is it, right? And it doesn't necessarily mean the same thing. So something that's a pillar that is in place is one level of evidence. A pillar that it was found in pieces lying on the ground, nevertheless you can pretty confidently put them back together and say that's where it was. 20 pillars in a row, 6 of them are missing, they're all the same, you're fairly sure, but the evidence isn't there. And the roof lintels, you've had to make them up. You might be absolutely certain about those roof lintels, and you might be less certain about the pillars because maybe there was one pillar that was different from all the others. Nevertheless, it's the kind of evidence rather than your level of certainty that you're recording. And there's the various recommendations and various implementations and so forth for that, of those sorts of systems that are out there. And I think it's very much the equivalent of using footnotes, this equivalent of using an apparatus criticus in a textual edition, right? You've got square brackets around this bit, and you say underneath, this is the person who first proposed this emendation. It's that sort of thing. We've got a 3D model. Yes, there might be nice visual ways to represent this for someone who's just looking at it, but someone who's using it for scholarly reasons, let's have actual, concrete paradata. I've also just posted a link to another video which is also on YouTube. It's a 20-minute video talking about best practice in documentation of this sort of thing. That we can do. If you're very interested, you can follow up with that. I'll leave that on the screen for a few seconds, as it's not a live link, so you may need to write it down if you want it. Actually, I don't need to leave it for a few seconds. People can pause. Thank you for the question, by the way. Very, very useful.
Yeah, great question.
Okay. Are there any other questions from the chat or comments from the people in the room? I think we are at time. Is that right?
More or less.
Yeah. Okay. I think we can close the session here. Thank you very much to our experts and speakers for this session. I also want to remind people of the next Sunoikis session, which will be, as Gabi mentioned, about another facet of 3D analysis, which is going to be imaging. So next Thursday, February 5th, we're going to have Megan Kasten and Mathilde Tuyon-Ricci talking about 3D and 2.5D imaging. So we hope to see everybody there. Thank you so much for following, and see you next time.
Thank you. Thank you for the invitation as well.